All right, welcome to section 6 on sequences. Let's dive in. An arithmetic sequence is the same as a linear function, but only has whole number inputs. A geometric sequence is the same as an exponential function, but only has, again, whole number inputs. So determine if the sequence is arithmetic, geometric, or neither. Let's see if this is adding or subtracting at a constant rate, if it's multiplying at a constant rate, or neither of those things. Let's see. Let's look like we're going down 3, down 3, down 3, down 3. So this is arithmetic. This 10, 5, 2.5, 1, 2.5, 0.625 looks like it's cutting in half each time, or multiplying by 1/2, multiplying by 1/2, multiplying by 1/2. So that is geometric. Create an arithmetic sequence that includes the point 4, 15 and 9, 35. So I'm really thinking about this as points in a table. I have 4, 15 and 9, 35. Change in the slope, m, is the change in y over the change in x. So m is changing, or x changing by 5, y is changing by 20. So the slope is 4. So if I'm thinking about this as y equals mx plus b, I can substitute a 4 into m, and I can take one of these points, it doesn't matter which one, and substitute into x and y. 15 goes into y, 4 goes into x, and plus b. I solve for b, and b is equal to -1. So I can write this equation as y equals 4x minus 1, or in sequence notation, the a of n equals 4n minus 1, or sometimes we say this first. So there we go. All right, creating an arithmetic sequence with these points. Again, I'm going to throw these into a table of x, y, or input and output. You could say this is n and an, whatever. We've got 3, -8, and 7, 4. So my slope, which is the change in y over the change in x, y changes by 12, and x changes by 4, so the slope is 3. Again, I'm going to substitute into y equals mx plus b. So I'll pick the second point this time. We get 4 equals 7 times 3 plus b. 4 equals 21 plus b minus 21 from both sides. B is -17, and we get y equals 3x minus 17, or in sequence notation, a of n equals 3n minus 17, or a of n equals -17 plus 3n. All right. Now I want to create an arithmetic sequence from a graph. So what's this equation for this line right here? Well, I'm going to do this the same exact way. I'm going to pick 2 points. Here is the, there's a bunch of ways to do this, but all right, I'll pick 2 points. You can see the slope is changing y over changing x. You can see it right here, 1, 2, 3 over 1. The slope is 3, but I'll just pick 2 points just for, I don't know why. Here we have a slope, or a point 4, 5. Here we have a point 3, 2. So if I look at change in y over change in x, I get -3 over -1, or 3. So the slope is 3. I can choose any point on this line. I don't even have to choose these 2 points. I could also choose this point, and I'll just do it to prove a point. So the y value, this point is 1, -4. So into y equals mx plus b, I'll sub in -4. M is 3. And 1 plus b, -4 equals 3 plus b. B equals -7. And that makes sense, right? It looks like if I connected these points into a line, where would I hit the y-axis? Well, it looks like -7 seems pretty legit. So the equation is y equals 3x minus 7, or in sequence notation, 3n minus 7. Okay, same thing over here. I only have 2 points. I'm trying to imagine, if these were a straight line, maybe it connects at 0, somewhere around 0. All right, let's start with the slope. M equals change in y over change in x. It looks like we got 1, 2, 3, 4, 5, 6, 7, 8, 9. And over 1, 2, 3. Slope is again 3. And so let's substitute that in, choosing one of these points. I'll choose this one, which is 2, 5. Y equals mx plus b. 5 equals 3 times 2 plus b. B is -1, so it wasn't 0, it was close, but y equals 3x minus 1, or in sequence notation, n equals 3n minus 1. All right, 2 more. I know I'm going through pretty quick. It is 10:47 at night, so I got to get to bed for school tomorrow. 2 terms of a sequence are given. A3 equals 54, and A6 equals 1458. Find a geometric sequence containing the terms, and find arithmetic sequence containing the term. So I just want you to conceptualize this for a second. If you have 2 points on a graph, any 2 points, all right, you can connect them into a linear function, or you can connect them into an exponential function. Any 2 points could, if it's just 2 points, it could be arithmetic, it could be a geometric, could be linear, it could be exponential. So let's show both. I'm just going to kind of cut this in half. Over here, I'll do the arithmetic. And this is the exact same thing I've been doing. M is the change in y over the change in x. So the change in x is 3, right? We go from 3 to 6. The change in y here, 1458 minus 54, that is 1404. And so 1404 divided by 3, that is 468. So the slope is 468. So now I can substitute in here. We're going to get output is 54. So 54 equals mx plus b, just so you see what I'm doing. Slope is 468 times 3 plus b. 468 times 3, that's 1404. Plus b equals 54. Minus 1404 from each side. And we get b is negative 1350. And so now my linear function is y equals 468x minus 1350, or y equals, in sequence notation, the a of n equals 468 n minus 1350. All right, so now we're going to do the same thing with a geometric sequence. And this is a little bit more math heavy. I'm going to set up a system of equations. So I know really we're using the equation y equals a times b to the x, because geometric is, let me just write that here. Geometric is exponential, so y equals a times b to the x. I just glitched. Are you kidding me? Hopefully you guys saved all of that, because it's all going to be gone. We're focusing on the geometric now. This is annoying. Y equals a times b to the x. Okay, now let's substitute in. So first one will be 54 equals ab to the third. And the second equation is 1458 equals ab to the sixth. And so I'm going to solve for a, divide by b to the third. So a is equal to 54 divided by b to the third. So I can substitute that into a. So I get 1458 equals 54 over b to the third times b to the sixth. Law exponent, since this is on the top, this is on the bottom, I subtract. We get 1458 equals 54b to the third. So we're going to divide both sides by 54. I'm not sure I can do this one in my head. 1458 divided by 54 is 27. 27 equals b to the third. Take the cubed root of each side. So I'm asking myself, what number times itself 3 times makes 27? That is 3, because 3 times 3 times 3 is 27. So b is 3. And we can substitute that back in to find a. Take this, substitute in here. A is equal to 54 divided by 3 to the third. 54 divided by 27 is 2. A is 2. B is 3. So in exponential form, we get y equals 2 times 3 to the x. In geometric form, we get g of n equals 2 times 3 to the n. All right, so we had our, it's gone, but we had our arithmetic equation. I don't remember what it was. I think it was this. 468 and minus 1350, something like that. So just seeing 2 points, they could either make a geometric sequence or an arithmetic sequence. Once you have a third point, you can figure out which one it is. But with 2, it could be either. All right, the third term of a geometric sequence is 5. The sixth term is 135 divided by 8, and the nth term is a big number. The solution to which of the following equations gives the value of n? I might have to make a separate video on this one. Well, I haven't thought about this one in advance, and it's not coming to me right away, so let's think. All right. How can I do this? The third term of geometric sequence is 5. So if the sixth term is 138 over 5. Well, we could figure out or 135 over 8. So let's, third term, so we could say the g of 3 is equal to 5. The sixth term, so the g of 6, is equal to 135 over 8. So what term, so g to the x equals this. That's essentially what we're getting at here. Well, let's think about it. I want to figure out what is b, so I can narrow this down. It's either 2/3 or 3 over 2, right? So let's figure out b. We have to make 2 equations, so we can say 5 equals a times b to the third, and 135 over 8 equals a times b to the sixth. Solve over here. So a is equal to 5 over b to the third, and let me just substitute that into a. We get 135 over 8 equals 5 over b to the third times b to the sixth, which simplifies to 135 over 8 equals 5b to the third. I'm going to divide each side by 5. 135 over 8 times 1/5. So we get 135 over 40 equals b to the third. This has to simplify, right? These can both divide by 5, so I get 127 over 8 equals b to the third. Cubed root of each side. B is equal to 3 over 2. So b is 3 over 2. So I can eliminate here, and I can eliminate here. So, well, I mean, the rest of this is pretty simple, because what is the difference between the 2 exponents it gave us? The difference is 3. So this x minus 3 is showing the difference in the 2 points that were given us. X minus 6 doesn't make any sense. We're given the difference here is 3, so we want to subtract 3, and we could use this equation to figure it out. All right, that's the end of section 6. One more section, and I'll hopefully wrap this up soon.